Welcome back, science fans. The past 24 hours have delivered a remarkable display of solar activity, as Earth experienced a geomagnetic storm triggered by a sudden solar flare last night, and space weather enthusiasts are now keeping a close watch on the Sun as more flares, alongside a coronal mass ejection, appear to be on the horizon. These events underscore the dynamic and sometimes unpredictable nature of our star, reminding us just how closely linked life on Earth is to the activity of the Sun. Coronal mass ejections, commonly referred to as CMEs, are enormous clouds of charged plasma that the Sun ejects into space. They travel at incredible speeds, carrying with them vast magnetic fields that can interact with Earth's own magnetic field. CMEs are often accompanied by solar flares, which are explosive bursts of energy on the Sun's surface. These flares occur when magnetic field lines, twisted and stretched by the Sun's rotation and convection, suddenly snap and release their pent-up energy, producing a brilliant burst of light and radiation. The combination of CMEs and solar flares can have significant effects on Earth, from dazzling auroras in the polar skies to potential disruptions of communication and navigation systems. Last night's solar flare was particularly notable because it emerged from a previously unremarkable sunspot on the Sun's northern surface. Initially, this sunspot appeared harmless, showing no signs of imminent activity. However, solar observers reported that it suddenly unleashed a powerful flare, demonstrating yet again the unpredictable behavior of our star. According to space weather.com, the flare was strong enough to ionize parts of Earth's upper atmosphere, causing a temporary radio blackout over Australia. Such ionization events interfere with high-frequency radio communications, which are critical for aviation, maritime navigation, and emergency response systems. The suddenness of the flare has scientists emphasizing the need for constant monitoring, as even seemingly minor sunspots can produce major disruptions without warning. In addition to last night's flare, solar observers have noted an increase in the number of new sunspots appearing on the Sun's surface. Sunspots are regions of intense magnetic activity, often cooler and darker than the surrounding areas. Their emergence signals heightened solar activity, meaning that the coming days could be marked by additional solar flares and CMEs. If these ejections are directed toward Earth, they have the potential to cause geomagnetic storms, which can disrupt satellite operations, damage power grids, and affect radio communications. While such storms rarely pose a direct threat to human life, their indirect effects can be significant, impacting modern infrastructure and technology-dependent systems in ways that are becoming increasingly critical as society grows more reliant on electronics and global connectivity. The implications of space weather are not limited to Earthbound systems. Surprisingly, aircraft are also vulnerable to the effects of solar radiation. Over the past weekend, it was reported that Airbus, the European aircraft manufacturer, recalled thousands of its A320 passenger jets after discovering a fault that could make them susceptible to intense solar radiation. According to Gizmodo, the radiation from solar events has the potential to corrupt data that is critical to the proper functioning of flight controls. This issue affected some major airlines, including Colombia's Avianca, which reported that approximately 70% of its fleet experienced complications as a result. The recall of the A320, which is the most delivered jetliner in history, has had widespread operational consequences, forcing airlines to adjust flight schedules and implement contingency plans. This incident highlights the real-world effects of space weather on aviation and transportation, emphasizing that no sector, from communication networks to commercial flights, is immune to the power of the Sun. Beyond aviation, the broader impact of geomagnetic storms on electrical systems and satellites is a major concern. Historical events, such as the infamous Carrington event of 1859, demonstrate the potential devastation of extreme solar activity. During that solar storm, telegraph systems across Europe and North America failed, some even catching fire, and auroras were seen as far south as the Caribbean. Modern society, however, relies far more heavily on electricity and satellite technology than the world did in the 19th century. Power grids can experience voltage instability. Satellites may lose control or suffer damage to their electronics, and GPS systems can become unreliable, affecting navigation for ships, planes, and even everyday smartphone users. Scientists and engineers are constantly working on strategies to mitigate these effects, including hardening satellites against radiation, improving space weather forecasting, and developing emergency response protocols for power utilities. Despite these efforts, the growing frequency and intensity of solar activity predicted over the next few decades suggest that such disruptions may become increasingly common. Interestingly, the study of cosmic explosions extends far beyond our solar system. Scientists have recently gained new insights into what a nuclear-like explosion in space might look like, thanks to observations made with Chile's Very Large Telescope (VLT). When massive stars exhaust the fuel needed for nuclear fusion, they can undergo a supernova explosion. The first light from these massive stellar deaths is not emitted uniformly in all directions. Rather, it emerges along a shock wave stretched along a particular axis, somewhat resembling the shape of a clam. This discovery challenges earlier assumptions about supernovae and provides astronomers with critical information about the dynamics of stellar explosions, the distribution of heavy elements in the universe, and the processes that can trigger the formation of new stars. Understanding these cosmic events also helps scientists predict the broader influence of space phenomena on surrounding environments, including potential effects on nearby planetary systems. On a completely different scale, recent research has shed new light on humanity's own history and migration patterns. Christina's recent article on the arrival of modern humans in Australia has captivated readers and reignited debates among archaeologists and geneticists. According to a new study published in the journal Science Advances, humans began settling northern Australia at least 60,000 years ago. This migration involved significant challenges, including crossing bodies of water that required the invention and use of watercraft, a remarkable technological and logistical achievement for early humans. The study also suggests that these early settlers may have encountered and interbred with archaic human species, such as the diminutive Homo floresiensis, sometimes referred to as the Hobbit. These interactions likely had important implications for the genetic diversity of modern humans and provide a fascinating glimpse into the complex web of human evolution. The arrival of humans in Australia represents one of the earliest known instances of maritime migration in history. Crossing open water to reach a new continent required not only physical ingenuity, but also sophisticated planning, coordination, and knowledge of the environment. Early humans had to understand currents, tides, and coastal geography, while ensuring the safety of their groups during perilous journeys. This migration event underscores humanity's long-standing capacity for innovation, adaptation, and exploration, qualities that remain vital to our species today. By studying these early movements, scientists are able to reconstruct the timeline of human settlement, identify potential interactions with other hominin species, and better understand the cultural and technological developments that shaped early human societies. In summary, the past few days have highlighted the interconnectedness of cosmic and terrestrial phenomena, from solar flares and geomagnetic storms affecting our technology and aviation systems to the extraordinary insights gained from studying stellar explosions. We are constantly reminded of the power and unpredictability of the universe. Meanwhile, research into human history, such as the pioneering settlement of Australia, illustrates the resilience, ingenuity, and adaptability of our species. Together, these developments, both astronomical and anthropological, paint a picture of a world that is deeply influenced by forces both near and far. As solar activity continues to ramp up, and as we uncover more about our own evolutionary journey, the importance of careful observation, rigorous research, and technological preparedness becomes ever clearer. Whether gazing at the sun, monitoring the safety of airplanes, or studying the footprints of early humans on distant continents, humanity's curiosity and perseverance drive us to understand our place in the cosmos and the story of life on Earth.